Okay, today we're going to talk about natural logs. And a natural log, it sounds really scary, but it's not, is just a log with a base of e. You know, the same e where when I have continuous compound interest or when I have a half-life. So first let's talk about the continuous compound interest formula. It's a equals a sub 0 e to the RT, where this a over here is the future value. This is my initial value. E is the number e, which is about 2.71818. And then R is the rate in decimal, and T is the time. So first example of solving with, or just evaluating with a function that has continuous growth or continuous decay. We have the weight of bacteria in a culture is given by W of t equals 2e to the 0.5 t, where t is the time in hours after the culture was set to grow. So we want to find the weight when t equals 0. All right, so we simply put in a 0 for t. That means no time has passed. Oops, that should be a 5. And we get 2e to the 0. E to the 0 is just like any other number, that is 1. So the weight is 2 units. All right, let me erase that. Now we want to find the weight when t equals 30 minutes. All right, well, t is the time in hours, so we have to take that into consideration. 30 minutes is half an hour. So that's the value I'm going to put in for t is 1/2. So the weight is going to be 2e to the 0.5 times, I'm going to write that as 0.5, which is equal to 2e to the 0.25. And that's going to be about 2.57, whatever my units are. All right, let's try one more. All right, we want to know what the weight is after 6 hours. One more time. That's going to be 2e to the 3rd, which ends up being about 40.2 units. Here's one for you to try. Stop the video, try it out yourself, restart it, and we'll check your answer. Okay, after 1 second, we have 75 times e to the negative 0.15 times 1. By the way, that negative means that this is decaying, that it's getting smaller. 75e to the negative 0.15, which ends up being about 64.6 amps. And an amp is a unit for measuring current. All right, and then after 10 seconds, negative 0.15 times 10 means I'm going to move the decimal one place, so I get negative 1.5, which ends up being about 40.2. Nope, wrong one. Which ends up being about 16.7. Need the pen. Okay, because we have all these applications of exponentials with a base of e, we need some way to undo an exponential with a base of e when we're solving for rate or time. So that's why we have the natural log, because it occurs because the base e occurs naturally, we need some way to undo it. So again, natural log is a log with a base of e, and it's on your calculator under the log button. E to the x is the second function below that. All right, so here's another example. I want to solve for x, and I have the natural log of x is equal to 2.17. Well, I have a log again, and I need some way of undoing the log in order to get rid of the log from the value x. And just like when I had log of 2 equals, or log of x equals 2, then I had to use an exponential base to get rid of it. I'm going to do the same thing here. I'm going to give both sides an exponential base, and the natural log is the inverse of e, so I'm going to give both sides an exponential base of e. This equals 1, which means that x equals 2 to the, or e to the 2.17. This is an exact answer, and depending on what it is you're doing, that might be appropriate, or it might be appropriate to find the decimal value of that, which ends up being 8.76-ish. All right, here's one for you to try. Pause the video, start it when you're ready. All right, so again, I need to give both sides an exponential base of e. That means that x is equal to e to the negative 0.384. So this would be an exact answer, and then depending on the situation, you might want a decimal. Okay. Let's talk about the laws of natural logs. Fortunately, they are the same as other logs with other bases. I have the multiplication rule, that natural log of m times n is equal to the natural log of m plus the natural log of n. And then I have the rules for division. The natural log of m divided by n is equal to the natural log of m minus the natural log of n. And then I have the power rule, which is natural log of m to the n equals natural log of m times n. And then I have these two important inverse properties. I have the natural log of e, and if that is equal to 1, because those are inverses of each other, you can go ahead and put that in your calculator. Just to verify that's true, go ahead, do the natural log of e, and evaluate it. You should get 1. And because these are inverses of each other, e to the natural log, then e to the natural log of x is just going to be x. If I had e to the natural log of 1, it would just be 1. So we're going to use the laws of logs to write this as a single logarithm. I have the natural log of 5 minus 1. So I need a way to represent 1 with a natural log if I'm going to write this as a single logarithm. And since the natural log of e is equal to 1, I'm going to substitute that. And then I have this subtraction here, so I'm going to write that as a division. And I'm done. Go ahead and try this one. All right, I have the natural log of 5 plus the natural log of 3. I can use the multiplication property here. And the natural log of 15 is it, and I'm done. All right, let's use the laws of log to simplify this. So I have 2 natural log of 7 minus 3 natural log of 2. I can rewrite that as the natural log of 7 squared minus the natural log of 2 cubed. And then I can evaluate the 7 squared. That's the natural log of 49 minus the natural log of 8. 2 cubed is 8. And then I can combine these, and I get the natural log of 49 divided by 8. Here's one for you to try. Stop the video, start when you're ready to check. Okay, let's rewrite this. Natural log of 3 squared minus 1, which is the natural log of e. Now I can combine, let's simplify the 3 squared. That's the natural log of 9 minus the natural log of e. And now I can rewrite it as 9 divided by e. All right, I want to write this without logarithms. So I have natural log of a equals 2 natural log of e plus 3. Natural log of a equals natural log of e squared plus 3 times the natural log of e. 3 times the natural log of e. Since the natural log of e is 1, then I'm left with 1 times 3. So I haven't changed the value. Oops, e squared plus the natural log of e cubed. I'm just rewriting that as an exponential so that I can combine this side of my equation more easily. Natural log of a equals the natural log. I can use the multiplication property now. E squared times e cubed. And then I get the natural log of a equals the natural log of e to the 5th. Now I can drop my natural logs. I have 2, if I have, then this means that a has to equal b. So that's the point I'm at now. A equals e to the 5th. Go ahead, give this a shot. Restart the video when you're ready to check your answer. Okay, so we have the natural log of m equals the natural log of a cubed minus 2 times the natural log of e. And then we can rewrite this over here as an exponential. Natural log of m equals natural log of a cubed minus the natural log of e squared. Now I can use the division property to rearrange that side. A cubed over e squared. And now I have the situation where I can drop the natural log. So m is equal to a cubed over e squared. All right, now let's try solving with logs. I have e to the x over 3 equals 21.879. I need a way to undo this because I have this variable in the exponent. So I need a way to undo the exponential. So that means I'm going to take the log of both sides. And that's going to bring my exponent down. So x over 3 times the natural log of e. But because I take the natural log of one side, I need to do the same thing to the other, or I won't have a valid result. Natural log of e is 1. So x over 3 is equal to the natural log of 21.879. And then I'm going to multiply both sides by 3. And I get x equals 3 times the natural log of 21.879. By the way, that is also an exact answer. Most of the time, though, you'll be putting that into a decimal. X is about 9.26. All right, your turn. Give it a shot. Okay, so first thing, I need to undo the 20 from this part, just because I have to go in reverse order of operations when I'm solving. So e to the 4x is equal to, oh, I forgot to tell you, I'm dividing both sides by 20. When I divide 0.00382 by 20, I get 0.00191. And then I have to bring down my exponent, so I need the inverse of an exponential. So that means I'm going to take the log of both sides. All right, since that's 1, then 4x equals the natural log of 0.00191. Divide both sides by 4. This would be an exact answer. Again, we're probably going to put it in decimal. I get negative 1.57. All right, that's it. See you in class.